And we're going to, there we go. Okay, everybody write that down. Don't say the answer out loud. And then I'm gonna say 1, 2, 3, and you can say the answer. And remember, oh, hi, Jason. How are you, buddy? Good to see you. Good to see you. And Jason, change your name to Jason, please. That would be easier for me. And remember, guys, always write your addition vertically. That means one number on top of the other. One number on top of the other. And what it does is it lines up the place values, the ones, the tens, and the hundreds. Okay, guys, on 3, 1, 2, 3, go. And just let's say it, not yell it, right, guys? Everybody say it together. Eleanor, you ready? Here we go. It's 307. And we always add the ones column first, then the tens column, and then the hundreds column. Now, what's interesting about this problem is that we didn't have to do any carries. So what if I then said to you, okay, let's double that number. And if you wrote 307 below the answer to 307, what would that be? And don't say it out loud, write it down and make sure that when you add your ones column, that you carry the tens digit, which in this case is a 1. And I always circle my carries. And that way it makes it clear that they are different from all the other numbers. Okay, guys, are you ready? And don't yell it, just say it. On 3, 1, 2, 3, go.
614.
That's right, 614. Now, what's kind of fun is that if we keep going, okay, it's kind of simple because there's no carries here. So as you can see, the ones column and the tens column are simple digits with no carries. And then the 6 plus 6, of course, is 12. And the answer is, remember, don't yell it, just say it. On 3, 1, 2, 3.
1,208.
1,228. Now, if I do this, you guys could do the same thing all day long. But what if we thought about, okay, we've got 2 1,000s, we've got 2 200s, we've got 2 20s, and whoops, hold on a second, it's not moving. Let's see, there we go. And we have 2 8s. Now, one of the things to think about here is, hey, you know that you're going to have 16 with the 2 8s, but it's so much easier to just put a 6 below the ones column, carry your tens, and then 2, 2, and 1 make 5 tens, and 2 and 2 make 4 hundreds. And on 3, the answer, 1, 2, 3.
2,456.
That's right. And remember, just say it beautifully. Don't yell it, just say it. 2,456. So this is the kind of question that we could have a lot of fun with. You could take any number and just keep doubling it and doubling it and doubling it until your hand falls off. And I like to do that a lot. So hopefully you will enjoy doing that with me as well. So the next question here is more of a pattern question. It's about a figure, and we can call it a geometric figure. Geometric figures are really cool. And this particular geometric figure almost looks like like the letter I, like a capital I with a hat and a foot, okay? But what you can see is that there's a pattern. This is called figure A. This is called figure B. And what they want to find out is how many more square tiles are in figure B than in figure A. And I know you can do the answer, but I want you to come up with a clever idea. So look at that. Tell me what might be a clever way of finding the answer. And I'm going to do a little coloring myself. So what do you think the answer is, guys? On three. 1, 2, 3. The answer is 6 more tiles. And how many of you counted all the tiles in figure B and all the tiles in figure A and then subtracted the figure A tiles from the figure B tiles? Did you do that, Eleanor?
Yes.
And what did you come up with for an answer for the total of figure B?
13.
Yes, very nice. And did anybody come up with an answer for the total tiles in figure A? How about you, Valerie?
7.
And when you subtract 7 from 13, what do we get? Go ahead, Catherine.
6.
Now remember, Eleanor, if I say Catherine, make sure you let Catherine answer it. So Catherine, did you come up with 6? Oh, I can't hear you, Catherine. I think that you're still muted somehow on your computer because you're not muted on Zoom, but you might be muted on the computer. And so I saw your lips say 6. And Jason, what's another way to do this besides looking at 13 minus 7? Jason, can you see a different way? Jason, can you hear me, buddy? Give me a thumbs up because I can't really see you. You're very bright light. It's almost like the sun is coming up right to you. Maybe it's a light that's reflecting. So Jason, are you able to hear me? Can you give me a thumbs up?
Yeah.
Okay, good. Can you answer the question? Did you come up with a different way or did you do 13 minus 7?
C.
So Valerie, how did, yeah, right?
Rectangle.
Say again, buddy. Jason, I'm waiting for you to tell me again, buddy.
Squares.
Ah, yes. Does everybody see that I drew the green squares. I drew 3 of them on top, 3 on the bottom, and 1 in the middle. And in the other figure, I did the same thing. 3, 1, and 3. And all I had to do is fill in the other squares with a different color, and I knew how many were added. Now, I've got a very special question for you. If we keep this pattern going, can you tell me, and we had a figure C, how many squares would figure C have, and what would it look like? So here we have 3, 1, and 3. I want you to look at what we have here and see if you could come up with the next figure and how many squares it has. So we know that figure A had 7. We know that figure B had 13. So I not only want you to give me the answer, but I want you to draw the figure on your paper. So get working, guys. Everybody pick up their pencils and make a beautiful drawing of this figure. And if you complete the task, drawing the figure and doing figure C, move on to figure D, as in David. Okay, so you can keep going till infinity. Okay, who would like to share with me their picture that they drew of figure C, as in cat? Who would like to share that? Did anybody get to draw it yet? Oh, that is beautiful. Jason, move on to figure D now. And Catherine, can you hold that with 2 hands a little closer to the camera? And, so Catherine, I'm not sure that that's going to be the next figure. I want you to look at this. Here, Catherine, we had 3 horizontally. Here, we have 5 horizontally. So, Catherine, how many do you think should be on the top of the next figure?
7.
Yes, the answer is definitely 7. And how many should be on the bottom, Valerie?
7.
That's right. And Eleanor, how many should be on the vertical that connects the 2 horizontal bars? What do you think, Eleanor? Any ideas? It can be a guess if you want it to be, but if you think about it, how many would you say are here? This is what Catherine said, 7, and Valerie said 7, but I want to know, Jason, do you want to help out? How many would be right here? Go ahead, Eleanor.
5.
That's exactly right. And if you add 7, 7, and 5, 14 and 5 on 3, everybody. 1, 2, 3, go.
19.
Right. Now, guys, how many did we add on to get the next figure? How many did we add on, guys, to get the next figure? Say it out loud.
6.
Right. So guys, figure A, figure B, figure C, figure D, figure E, figure F, dot, dot, dot. We know that the first one had 7, then 13, then 19. How many would figure D have, everybody? If we keep adding 6, adding 6, adding 6, what is D?
25. 25.
And what about E?
31.
And that would be 31.
31.
Nice. And what about F?
37. 37.
Right. Now, here is something that I teach the older kids. When I teach the older kids this, I would ask them how many would be letter Z. Now, we know that that would be the 26th. That Z would be the 26th letter. A is the first, B is the second, C is the third, D is the fourth, E is the fifth, and F is the sixth. But Z would be the 26th. Now, it's a really, really fun thing to do. And what you have to do, Z at 26, is you would actually be taking the first number 7. Now, we're not going to actually do this, but I want you to see what I teach the older kids. And if we add the number 6, which is the number that gets added to each one, and then we multiply it by 26 minus 1. Now, can you believe that that would give us the answer for the Z figure? Now, who can tell me, just for fun, what is 26 minus 1? I bet you might know that.
25.
Wait a minute. So you're telling me that we have to multiply 25 times 6, and then we have to add 7. Remember, we never do addition before multiplication. You always do your multiplication first. Now, I want you to raise your hand if you know how to count by 25 6 times. Don't give me the answer. Just raise your hand if you can count by 25s. 25s are really, really cool. Okay, let's do it together as a team. Are you ready? 25.
25. 50. 50. 75. 100. 125.
And finally,
150.
now notice, guys, how the 25 and the 25 and then the 50 and the 50, and this is 1, 2, 3, 4, 5, 6 25s. That means that if we take 150 and we add 7 to it, we will get the answer. Are you ready? On 3. 1, 2, 3. Say it, please.
157.
Now, that is a pretty cool number. And I'm going to tell you that this is on page 3. The document that I will send you right after this class is on page 3 is going to be this problem. Now, you may say, you know what, Mr. Kramer, I believe you, but I want to check it. So you go G and H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. And if you come up with 157, then you know that what we did was perfectly correct. Remember, we add 6 every single time. Is anybody gonna check Mr. Kramer's work this week? Is anybody gonna do it? Come on, guys, you've got to do it. And have your parents send me a text and say, oh my God, Mr. Kramer, it was wrong, or it was correct. All right, so let's have some fun with that and fun with the alphabet, because the alphabet is so amazing. All right, so the next problem here is about age. And I'm going to read it to you because not everybody can read yet as perfectly as everybody else. So Mr. Kramer likes to read as well. Are you ready? George is 48 years old. Emily is 5 years older than George, and she is 9 years younger than Hannah. How old is Hannah? So I want everybody right now to write down a G for George, an E for Emily, and an H for Hannah.
Well, we're done.
Now, the only thing I'm going to tell you is that G is 48, because that's what they tell us in the first sentence. You have to find out how old Hannah is. But please do not say the answer out loud. And you can actually use algebra. As you can see, we are using algebra by giving letters values. G is 48. And it looks like Valerie and Jason have an idea, and Eleanor. Okay, and I'm not sure if Catherine, if you have your hands up. Oh, you do. Everybody say Hannah's age. On 3. 1, 2, 3. Okay, I heard. Okay, nobody's allowed to yell numbers anymore. I want to hear from everybody. So Eleanor, what did you think the answer was? Just say the nice number. Because I want to write down everybody so I can hear, because I heard different numbers. So Eleanor?
62.
62. And what about you, Catherine?
I think it's 14.
14. And what about you, Valerie?
62.
And Jason?
62.
Now, I want to look first at Emily. Emily is 5 years older than George. So we could write that as G plus 5, because George plus 5 equals Emily. And 48 plus 5, Catherine, equals what? What is 48 plus 5, Catherine?
53.
That's perfect. Now, it says that he, and she refers to Emily, is 9 years younger than Hannah. So Hannah is Emily plus 9 years. So do you see, Catherine, that we have to do what to 53?
Plus
53,
9.
right. And 53 plus 9, everyone, is
62.
Now, what's interesting, Catherine, is what you answered is actually the amount that George, and so Hannah equals George plus 14. So, Catherine, do you see how the 14 is George? Hannah is George plus 14. Does that make sense, Catherine? Okay, great. And great job, everybody. The algebra is beautiful. You don't have to do it algebraically, but it's so much fun to do that. Okay, so this one is kind of a good one. And I think, let us try that one there. So we have a shoe rack that can hold at most 7 pairs of shoes. What is the smallest number of shoe racks that Elena needs to store 32 pairs of shoes? So we want the smallest number of shoe racks if she's got 32 pairs of shoes. So some people like to do this with pictures. Some people like to do it just with numbers. And some people like to do pictures and numbers together, which I really like. And Jason, why don't you tell us what you came up with here and how you did that? Okay, buddy, go for it.
32 divided by 7 equals 4. Remains 4. 5 shoe racks.
Ah, so 32. Everyone look up, please. 32 divided by 7. And you can write it as a fraction, or you can write it with a division sign. I prefer the fraction. It equals 4 with 5 left over. So 4 with, oh, I'm sorry, with 4. Did you say 5 left over, Jason, or 4?
5.
Let me think about that. How many do you guys, Eleanor and Valerie and Catherine, think might be left over?
4.
Oh, so Jason, you're changing your answer. And I think you're right,
Yes.
Jason. I think you're right that it is 4/7 left over. But are we allowed to buy 4/7 of a shoe rack?
No.
So I'm going to ask Valerie. Valerie, do you know what is the smallest number of shoe racks that Elena needs to purchase? Say again, please.
I
And I want to ask you, Valerie, will 4 shoe racks be enough?
No.
Okay. Are you allowed to buy a part of a shoe rack, or do you have to buy a whole shoe rack?
A hole.
Therefore, how many shoe racks will she need?
I think
Go ahead and say what you think, Valerie.
10.
Okay, 10 is one possible answer. But remember, Eleanor and Catherine, what do you think is going to be the number of shoe racks that she'll need? Eleanor and Catherine, raise your hand if you want to give it a shot. Go ahead, Catherine.
I think it's 5.
And Eleanor, what do you think?
5.
Yeah, because Valerie, as you can see, 4 is too small, but she only needs 5 racks because Jason showed us that 32 divided by 7 is a little more than 4. So therefore, in fact, it's more than 4.5. So she is going to need 5 shoe racks. Now, let's just say that Elena had 700 pairs of shoes. Well, that's a lot of shoes, don't you think?
Yeah. Yes. Yes.
How many shoe racks would she need? Raise your hand if you know how many shoe racks she would need. Because all we're doing is dividing 700 by 7. 700.
100.
And Jason, I want you to raise your hand, buddy. Really important because that way everybody else gets to think on their own. But Jason is right. 700 divided by 7, of course, is 100 because 100 times 7 equals 700. That is pretty cool. Now, we are going to do a lot more problems like that because it's really cool to be able to understand the division, but also understand what they're actually asking. And that's the hardest part. Okay, the next one we're going to do has to do with flowers. Kathleen bought a bouquet of 6 flowers, as you can see, and a vase for a total of $29. Now, the flowers cost $4 each. How much did the vase cost? So I want you guys to think about that. You could you could draw a little vase, and if you want, you could put 1, 2, 3, 4, 5, 6 flowers, and maybe you could write numbers in them. You know, you could say, well, we know that the flowers cost $4 each. But we know that the whole thing together costs $29. So the question is, how much does the vase cost? And don't yell out the answer, please. Write it down. And if you could come up with an algebraic equation, that would be pretty cool too. All right, so I'm going to ask first to see, Catherine, what do you think is the cost of the vase?
I think it's 25.
Whoa. Does anybody else agree with that? And Jason says yes. Eleanor, did you have a different answer?
No. No.
So now, did you say 25, Catherine?
Yeah.
Okay.
Oh.
And Jason, you think it's 25 also?
No.
What do you think it is, Jason?
5.
$5. Now, Eleanor, what are you thinking? Are you thinking 5, 25, or a different number? And Valerie, I'd love to hear what you have to think as well. How many of you added the 6 fourths? Come on, guys. What is 6 times 4?
24. 24.
Of course. So if 6 flowers cost $24 and the total cost $29, if we subtract 24 from 29, everybody, what do we get?
5. 5.
We
5.
get 5. So the vase must have cost $5. $5. Now, I want to ask you a different question. What if I'm going to say the flowers now cost $2 each. How much does the vase cost? So if the flowers cost $2 each, how much would the vase cost? And I will tell you, flowers, $4 per flower is a lot of money for flowers. I usually pay about $2 for my flowers. And remember, don't call out the answer. I want you to write it down so everybody has an opportunity to think about it. All right, Valerie, I want you to give us your answer, and then I want you to explain the cost of the vase. Go for it.
Answer for what?
What's the answer for the vase if the flowers cost $2 each?
7.
7. Interesting. Does anybody else have a different answer? Valerie, how did you come up with 7, please? Valerie, go ahead, honey.
Before it costed $4 for each of the flowers, and now it's 2, and take away 2, and for the vase it was 5 before, so I have to add 2, and I got 7.
Got it. Valerie, your explanation was so clear, so clear. Now, there's something, Valerie, I want you to think of a little bit differently. Eleanor, did you have a different answer?
Yes.
What was your answer, honey?
17.
Aha. Can you explain why you said, and Valerie, I want you to really concentrate on what Eleanor is going to say right now. Go ahead, Eleanor.
Sixties equal 16 and 29.
Oh, wait. Hold on a second, sweetheart. 6 times 2 equals what?
16.
Think about it again. I know that 8 times 2 equals 16. What is 6 times 2? And what did you get for that, Eleanor? Eleanor, would you like some help, sweetheart? Catherine, would you be able to help her?
Yes.
Go for it, honey.
6 times 2 equals 12.
So Eleanor, do you see that 2 6s equals 12?
Yes.
And then what did you do
Okay,
with
yeah,
the 12, Catherine? Does anybody want to explain what we do with 29 and 12? Go ahead, Jason.
29 minus 12 equals 17.
Eleanor, your answer was correct. It is 17, but it's not because 6 times 2 is 16. It's because 6 times 2 is 12. And when you take 12 away from 29, you get $17. And a really nice vase could definitely cost you $17. So Eleanor, does that make sense?
Yes.
Excellent, excellent. And Valerie, does that make sense to you, honey?
Yes.
Because Valerie, what you did is you were thinking there was 1 flower, but there were 6 flowers. So you had to first multiply 6 times 2, just like here we did 6 times 4. Then we subtracted it from 29. So this is a very challenging question, but a really good one for everybody. Now, the next one, I'm going to read it out loud. There are 2 showings of a movie called Firestorm. Now, Delia arrived at the theater 40 minutes after the, wait, somebody's yelling, guys, in the background. If that's you, go see if you can ask them not to be yelling in the background. And maybe it's coming from Valerie's. I'm gonna give her a little mute here. Yep, I think that was it. I apologize, guys. Okay, here we go. So Delia arrived at the theater 40 minutes after the first showing started. Now, the first showing started at 7:30. That we call the first showing. It started at 7:30. Delia arrived 40 minutes after the first showing. So the question is, how many minutes does she now have to wait until the start of the second show? And we know that the second show, this is the second show, starts at 9:20. So I want everybody to think about that. And Valerie, I'm going to ask to unmute you now because there was some loud noise coming from your place. So we muted you. So you can unmute yourself. Jason, you can unmute yourself too. And let's see if you guys can answer the question. Please do not call it out. I want you to write it down. Remember, she arrived 40 minutes after the first show. And the question is, how many minutes does she have to wait before the next show? So raise your hand if you think you know how many minutes. Anybody have an idea? You might start with, hey, what time did she arrive at the theater? If it was 40 minutes after 7:30 p.m. So raise your hand if you think you know. Okay, Jason, what time did she arrive?
8:10 p.m.
So she arrived at 8:10 p.m. Now, Eleanor, Catherine, and Valerie, did you all get 8:10 or did you get a different time that she arrived? Now, guys, remember, from 7:30 plus 30 minutes is going to be 8 o'clock. So if she arrived 40 minutes, that means we have to add 10 to 8 o'clock. And I agree with Jason. It is 8:10. Now, how many minutes are there between 8:10 and the second show? Remember, the second show starts at 9:20 p.m. And the big fact that you all have to know here, that 1 hour equals how many minutes? Raise your hand if you know. Okay, go for it on 3. 1, 2, 3.
60.
60 minutes.
60.
So the question is, how many minutes do we have to add from 8:10 to 9:20? So raise your hand if you know how many minutes. Make sure you write it down. Now, Eleanor, I'm going to let you take this one. How many minutes is it going to be from 8:10 until the second show?
70.
Wow. How did you get 70 minutes? Because you are 100% correct. How did you get 70?
60 plus 10 equals 70.
Oh, wow. Do you guys all see that what Eleanor did is she went from 8:10 to 9:10 first? And look at that. That is 60 minutes. Then she added another 10 minutes and she got to 9:20. 60 plus 10, 70 minutes is correct. That was awesome, awesome, awesome. Great job, guys. Great job. Now, the next question I'm going to give you has to do with players on a basketball team. And I'm going to read it to you and then let you think about it on your own. There are 8 players on the Blue Sharks basketball team. At the last game, Zane, the team captain, scored 10 points, while all the other players scored 4 points each. How many total points did the Blue Shark basketball team score? Now, I'm going to read it one more time. There are 8 players on the team. At the last game, the captain scored 10 points. All the other players scored 4. How many total points did the team score that night? So I am going to let you guys think about this. I see that Jason's got it. And Jason, make sure you write down the answer. And if you can write an algebraic expression, even better. Remember, each of the other 7 players scored 4 points each. So now we have Zane with 10, the other players with another number, and the total that the team scored on 3, 1, 2, 3, go.
28.
And now, what did you get, Catherine?
I think it's 14.
14. Now, Catherine, that would be true if all the other players scored only 4 points. But they scored 4 points each. That means that, let's say one player was Eleanor, one player was Mr. Kramer, one player was Catherine, one was Valerie, one was Jason, one was Stella, and one was my friend Craig. That's 7 people. So Catherine, each of those 7 people scored 4. So everybody, 4 times 7 is what?
28. 28.
And Jason added 10 to 28 to get 38 total points. And that is the answer to this question. Now, I'm going to ask it a little bit differently. I'm going to change this just a little bit, and I want you guys to watch this. I'm going to change Zane. Whoops. I'm going to change Zane. Whoops. Hold on. It's not going to work. Hold on one more second here. And there we go. Okay. So I'm going to say that Zane scored 15 points and all the other players scored 5 points each. What were the total points? So Zane scored 15 and the other 7 players scored 5 points each. What was the total? All right, Catherine, what do you think about this one?
I think it's 35.
Okay. And Valerie, what do you think?
37.
37. And Eleanor? And Jason, what about you guys?
35.
55 and 37.
35.
Oh, 35. Sorry, 35. Yeah, so I do not agree with any of those answers. Eleanor, do you have a different answer?
50.
Aha. Now, everybody, we've got 3 potential answers. We've got 35, 37, and 50. Now, Valerie, what is 7 times 5? Wait, Jason. Valerie, what is 7 times 5? You can count on your fingers 7 5s, or you know the math back. Or you can do 5 7s, but that's a little harder.
35.
So the other 7 players, Catherine, the other 7 players, Jason, scored 35 points. But Eleanor, what did you do to get 50?
35 and 15.
Right. So you added 35 plus 15 and got a total of 50 points. So Valerie, does that make sense to you? Yeah, and Catherine, give me a thumbs up if it does make sense. And Jason as well. Jason,
Yeah.
okay, good, good. Remember, we can't just answer the 7 times 5. We have to think about Zane, who is our team captain. Okay, Zane is our team captain. And what if everyone scored the same number of points? And I'm going to tell you right now, you ready for this? They each scored 10 points. 8 players, they each scored 10 points. On 3. 1, 2, 3.
10, 8 times 10 equals 18.
Beautiful, beautiful job. 8 times 10 equals 80. And you guys are amazing. You have just answered seven questions from a 3rd grade math competition. Now, as we go higher in the numbers, I think there's 25 questions or 20 questions, it gets harder and harder and harder. So who is ready for that challenge? And I'm just thinking that Eleanor is wearing a shirt. She needs to show everybody. So Eleanor, show everybody that challenge shirt that you got. You see that? It says challenge done. So I want you guys to take the challenge and work with me. I also want you to check my answer. Remember this? On this problem right here, check to make sure that my answer of 157 was correct. And you can use these other pages to answer that problem. All right, guys, it was great, 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 great to see you. And I will see you next week. And I will videotape it again because I videotaped it for Stella this week, for Valerie next week. And I'll see you guys soon. All right, say goodbye to your friends.
Bye. Thank you. Bye.
You're welcome. You're welcome. You're welcome.